Okay, so today we're going to actually look at determining the concentration of a solution. Before we can do that, we do have to define a couple of things about terminology when it comes to a solution. And a solution is essentially made of two components. One, a solute, and another is a solvent. The solute is what gets dissolved into the solvent. And in our particular case, we're going to be calculating concentrations of solutions essentially by determining how much solute is within a solvent. And more often than not, our solvent is going to be water. So one of the ways you can calculate a concentration that chemists use is a terminology that's based off of a value that we know how to calculate, and that's called the mole. And it turns out that when we determine how many moles of a solute are put into a particular volume of a solvent, we are calculating a term called molarity. So molarity is a unit, and we use a capital M as the unit, and this is how it is actually calculated. So it turns out molarity is the moles of solute divided by the total volume of the solution that is created. Because it turns out that whenever you have a particular solvent at a particular level, say on a graduated cylinder, if I were to take and put in, say this is sodium chloride, into some water in a graduated cylinder, the volume of the level of water will increase when I add sodium chloride to it. So when we're calculating molarity, make sure that we understand that this is the volume of the final solution, aka the now increased volume. I will almost always give you the total volume of the solution, not the volume of the initial amount of water when calculating these problems. So let's do a few examples so that we can see how this works. So in this particular problem, it says determine the molarity of the following. And it says that you have 0.444 moles of cobalt 2 chloride in a volume of 0.654 liters of solution. And one of the things that I failed to mention earlier was that the volume that we use in our molarity calculation must be in liters. Okay, so to calculate that, we're going to just use our very simple formula of molarity, and that equals the moles of solute divided by the volume in liters of our solution. And so this is actually a quite simple problem. We just put our 0.444 moles divided by our 0.654 liters, and that will give us a value in 3 sig figs of 0.679, and capital M will be our unit, and you should always say of what solute formula. That's cobalt 2 chloride. And the way that you would read this answer here would be 0.679 molar cobalt 2 chloride. And so we say this capital M as molar. So you wouldn't say it as 0.679 molarity cobalt 2 chloride. You would say molar instead. So it's a pretty simple calculation. How about we try one more? So in this one, it says determine the molarity for the following, where you have 98.0 grams of a solute called phosphoric acid in 1.50 liters of solution. Well, in this particular case, we've been given grams of a substance rather than moles. So this is going to take and add in additional kind of calculation processes that you guys have learned before, where we're going to have to figure out how many moles of that substance. So in this particular case, what we're going to do is we're going to take our 98.0 grams of H3PO4, and we're going to have to convert that to moles. So we'll use the molar mass of phosphoric acid, which I've already calculated to be 224.89 grams. Remember to write your complete units. I know you don't want to, but you need to. And that is equivalent to 1 mole of H3PO4. And then that in 3 sig figs ends up being 0.436 moles of H3PO4. And now we're ready to go just like we were in our previous problem. So we write our formula of molarity equals moles over liters of solution, and we just plug in our moles of 0.436 divided by our liters of 1.50 liters, and that ends up being 3 sig figs calculated to be 0.291 molar phosphoric acid. Okay, let's try another one, just so you'll have a couple of examples. This problem says calculate the number of moles of the solute in the following. So this time you're given molarity here of 18.5 molar, and now asked to calculate the moles. So we're going to be kind of going backwards from what we have done previously. And with this particular one, what we'll do is we'll go ahead and we'll write our formula down of molarity equals moles per liter, and we'll kind of check off what we have. We know we have the molarity, and we also know we have the liters. So we're going to be solving for moles. And you can solve the formula before you plug numbers in, or you can go ahead and plug the numbers in and then solve for the unknown that you need. Essentially what this is going to end up being is that when you solve for moles, this will end up being molarity times liters. And so we can just plug it in that way. So the molarity is 18.5. The liters are 2.00. And when we solve for that, we end up getting 37.0 moles, and we'll say of our solute of H2SO4 or sulfuric acid. And so that's how you do that. If you don't like solving for it like this, and then plugging your numbers in, then and I don't typically, but if I don't solve for it, I just do write my formula here, and then I'll go plug in my numbers of my molar solution as being 18.5 molar, and my moles as my unknown, and my volume of 2 liters. And one thing that you can note whenever you're trying to solve for this guy is that what you would do is kind of this roundabout kind of thing. If you multiply the denominator on the right hand side, the 2.00 liters, times the molarity on the left hand side, that will, so you multiply here, that will equal the moles there. So that's one shorthand way you could do it if you want to shorten the amount of time it takes you to solve this problem. Okay, so let's try one more just like that, and then we'll be done with this particular lesson. So in the last problem, it says calculate the mass of the solute. So this time, instead of calculating molarity or moles, we're going to go a little bit further on in our steps to calculating the mass of the solute. So you're starting with 5.50 liters and the 13.3 molar solution of H2CO, which by the way is actually the formula for formaldehyde. And that's what we use to fix tissue. If you are taking a sample of tissue and wanting to preserve it for years to come, that's what we use. So to solve this problem, first, before you can figure out the mass, you need to know the moles of that substance. And so we can do that just using our classic molarity formula of molarity equals moles per liter. I'm going to do this the kind of shorthand way and putting the 13.3 molar on the left and the 5.50 liters on the denominator and my moles in the numerator. And I'm going to multiply these two numbers, which will give me the moles on the numerator. And that ends up being a value of 73.0 moles of H2CO. Now we can take that value and convert that to mass. And so if we start with our 73.0 moles of H2CO, we can convert that using the molar mass, where 1 mole of H2CO is equal to its formula mass of 30.03 grams. And that would cancel moles and leave us in the unit of grams. When you do this, it actually gives you a number of 2,192.19 kind of in your calculator, but you need to maintain significant figures of 3 sig figs. So that means you can go as far as the tens place, and so we will round that at 2,190 grams of H2CO. Okay. So these are kind of the major examples of how you might calculate molarity, and it's a pretty simple formula. There is a way to do all of these using dimensional analysis, but for now we're going to start just by using the formula that you see here. So I would keep that in my notes as to calculating and solving problems dealing with molarity. Okay, I'll see you in a little bit.